Once we have covered the basics of the Python, now it's time to dive a little bit deeper into more advanced data types. So one of the data types that are quite common in Python is the lists. But before we move forward and know what a list is, it's very important to understand the key state of the problem. Usually in oil and gas industry and most industries, we have either something called spatial data or we have called temporal data. So temporal data are the data that are related to time, spatial data that are related to the geographical location of the data itself. So usually any form of data that we have, no matter if it is spatial or temporal, usually you will have for a particular field or a particular asset or an equipment, you have multiple data at the same time. So you usually capture this with time or you capture this with depth or length, no matter the capturing method is, usually you have multiple values at the same time. So for example, if you have, for example, the pressure, and you are basically representing the pressure with depth or versus the depth. So the depth is going to be on the y-axis. Usually having a variable like pressure equals to, for example, 1000, it's not enough. Why is this? Because this is a single value. It's a scalar. It's just one value. But what we are trying to do is we are trying to represent pressure with depth. So we need multiple values. That's why in Python we have supports for something called lists. A list is a data type that can support multiple values at the same time. To create a list, usually you open up a square bracket and you close off a square bracket. And any values you have in this is going to be saved in a particular location in the memory, and it's going to be a variable with multi values. So let's see how this is usable in Python. First of all, let's create a variable called pressure equals to open close square brackets. So once you have a square bracket, now it means that you're trying to create multiple values at the same time. So let's say that the pressure at the first point is 0, the second location is 100, the third location is 300, fourth location is 500, and the final location is 700. Now, just see how many values we have. 1, 2, 3, 4, 5. We have 5 values. More properly, in the terms of Python, this is known as 5 elements. Yep, these are called elements. So the first element, second element, and so on and so forth. Let's create another variable called depth, and we will have also 5 elements in these depths. I will make both of these at the same level so you can basically see for yourself. So at the first depth we have 0, the second depth is, for example, 200 meters, the third depth is 500, the other depth is 1000, and the final depth is, let's say, 1300 meters. Now we have two lists. Now, how can we benefit from these lists? These lists basically can be used for wide range of activities and wide range of things. For example, you can use them for calculation, you can use these lists for plotting and whatnot. So let me show you how we can use these lists for plotting. Usually in Python, if you want to, let's say, plot something, Python does not support this. Usually, we will use an external library for these activities. So let me show you. In order to call a library that allow us to plot something, usually we use the keyword import. So import is basically the keyword that's responsible for getting libraries or functionalities that allow us plotting. By the way, if you feel that you do not understand this yet, don't worry. In the upcoming videos and upcoming sections, we will have dedicated sections for plotting and working with external libraries. So let's import the library that is responsible for plotting. For this example, it's going to be mat plot lib.pyplot as PLT. Now we are importing the all library that's basically responsible for plotting, and then we are calling it PLT because the library name is too much. The keyword that you see in front of you as this is known as aliasing. It's basically taking the variable name, or let's say taking the library name, and then just we are calling it PLT just inside this code. Okay, so outside of this code, the library is still called matplotlib pyplot. So we are just naming it PLT for the sake of simplicity. Now, if you want to plot both of these things, pressure and depth, we can do something like this. PLT dot plot. By the way, in Python, if you want to access a functionality or a child functionality or a sub functionality in this library or any given library, you will use dot. So dot plot is going to command matplotlib to create a line plot for us. So what we are trying to plot, we are trying to plot pressure versus depth. And yes, the plot is a function, and any function in Python opens up or starts and ends with open braces and close braces. And anything between these braces are the inputs for this function. And we have only two inputs. The first input is the x values, and the second input is the y values. So if we click on run, you should get a plot that's looking like this, which is the pressure against your depth. The y-axis is the depth and the x-axis is the pressure. Sometimes people feel that they don't want to see a line chart. Maybe they want to see a scatter chart. So can switch this to scatter chart just by replacing the plot. Click on scatter. There we go. Now these are your dots. Now this is one of the main objectives of using lists. It allows us to create plots and calculation. Let me show you one more thing. If you want to add, by the way, if you want to add more data to this list, because let's say that your lists only contains 5 elements, but once you run the code, you want to add more elements to this list. Let me show you. We will call the list that we are working with, for example, pressure dot. Now, whenever you type dot, it means that you're trying to force or you're trying to insert a particular property onto this list. It means that you're trying to create some actions on this list. One of the actions is called append. Append is going to add one value at a time to the end of the list. For example, let's add a value of 900 to the end of the list. Okay, let's do the same thing for the depth. So depth dot append. Now we're going to add one more value to the end of the depth. Let's call this 1500. So if we click on run, you'll see now the new chart is going to change, or the range or the effective range of the chart is going to change as compared to the other charts. This is the first chart, it's ending at 800. Now this is the second chart, which is ending at 900. By the way, if you are following along and you don't see these plots showing up, it's possible that the plots are not set up properly. So let me show you how we can set up the plot visualization properly. Next to the variable explorer, go to plots, and you will see all the plots are appearing also in this section. Once you click on the plot, navigate to the right hand side, go to the top. There are these 3 lines, which are the options for the plot. Click on it and make sure that you deactivate this line. You will uncheck mute inline plotting. Once you have this, it will basically not visualize anything on the output section. So make sure that you have it just like this, which is unchecked mute inline plotting. So once you have this, you will also see the plot showing up. Once you click on run, everything now is working fine. Now there is one problem with the Python representation of the lists. By the way, in Python, this is called list. In mathematics, this is called vectors. There is one fatal drawback of these lists. Let me show you. Let's calculate the pressure in bar gauges. Okay, so we are going to take these pressures and multiply it, divided by 14.5 to convert these into bar gauges. So equals to pressure divided by 14.5. Now, usually if you do such a thing in MATLAB or in Excel, this is just okay. Everything is expected to be divided by 14.5 to convert this into bar gauges. Now, once I run this, you will notice a very, very weird behavior in Python. There we go. It says that type error, unsupported operand for list and float. By the way, an operand is these mathematical expressions, which are mathematical symbols, which is the division, multiplication, addition, and subtraction. These are known as operands. Anything you have to the left of the operand and to the right of the operand are known as the operators. Why this is happening? Because by default, Python does not support any mathematical in vectors. So any vector mathematics that you know uh, from from high school or from college, this is not supported in core Python or in standard Python. Of course, there are alternatives or there are solutions to this, but yeah, this is not possible. And if you think that you can go ahead and multiply the pressure by 14.5, just like this, well, guess what? If you run this, you're going to get the same error. You cannot multiply. But if you multiply this, for example, by 10 and run this, suddenly everything started to work. And the behavior is not what you're expecting. If you go to Variable Explorer, click on it, and then just look at the pressure in bar. Click on it, and what's happening? It's basically repeating the values. It means that this list was multiplied by 10 and it repeated this list 10 times. Okay. By the way, this is one of the ugly behaviors you have in Python where Python cannot work with lists very effectively or it cannot do vector mathematics. But Python has one trick at its sleeve that's going to make everything fall into place.